Right, 10.1, we're going to look at what we call matrices and systems of equations. So we've already looked a little bit at systems. We looked at solving through graphing, substitution, elimination, and then also a bigger set there. But another way to look at systems is through what we call matrices, or a matrix, when we bring it down to a single term there on a non-plural for that. So we want to look at those here today. So we got quite a few definitions again, so I'm going to bring that up on the computer screen. We'll talk through those and then look at the examples there that we have for that. Okay, so let me bring that up. So let me share my screen. All right, so here, first of all, we need a system to be able to talk about our definitions. So the first thing there is putting up just a simple 2x2 matrix. When I say 2x2, meaning 2 equations and 2 variables. So that's what we're looking at there for those. All right. So 2x minus 3y equals 7. X plus 4y equals -2. That's my system that we're going to look at. Now, first of all, a matrix is a rectangular array of numbers. It's just a collection of numbers within those. So we usually use them in a specific way based on whatever we're doing. Computers, they use matrix all the time, but here we're going to use them dealing with systems. Okay. Our second definition there, augmented matrix. This contains the coefficients and constants. So you're going to see a few things there. Our first column is going to deal with the x variable from our system there. The second column is going to deal with the y variable. Sorry, I'm writing with my mouse here, so not very good handwriting, but we can see that there. The bar in the middle is our equals sign, okay? And then what it equals is the numbers on the other side, okay? So again, I apologize for the crappy handwriting there, but when you do it with a mouse, it is not very easy to do. But we get those things straight from those. So some of your questions are going to say, write the augmented matrix. And so you just pull those numbers. Okay, that's a very straightforward part of the question. All right. The next is the coefficient matrix. This is just the coefficients. So notice it is only the first part. We did not have the equals and then numbers afterwards. Definition number 4, we have what's called rows and columns. So our row is what's going to be going across. That's your equation, essentially. And then your columns, the up and down for those. And so that allows us to talk about the size or the order of the matrix. So when we talk about the order, that is rows by columns. Okay. And so they kind of give an example here in number 6. If I have this matrix listed there, we can see there are 2 rows. So let me annotate that. So row number 1, row number 2. Okay. And then columns, we have column 1, column 2, column 3, and that gives us the order of a 2 by 3. And then each one of these things, the A, B, C, D, E, F, these are called elements. Okay. All right, now our last 2 are going to deal with solving. So number 7 there, what we call Gaussian elimination or Gauss-Jordan elimination. This is a way of solving systems. So that's going to give us our 4th method for solving there on those, okay? And if I tell you you have to use that method, you must use it, okay? Graphing you must use, and Gauss-Jordan or Gaussian elimination you must use when it gives those instructions. I will allow you, when it says substitution or elimination, to switch those, whichever one of those 2 you like, when it gives that instructions. But if it says to use Gaussian or Gauss-Jordan elimination, you must use a matrix to solve. It says graphing, you must graph it because you physically have to put that in a computer. All right, now things that we can do under Gaussian elimination or Gauss-Jordan elimination, we can interchange 2 rows. We can multiply a row by a constant, or we can add one row to another. And you'll see me do that here later in our examples. And then finally, number 8 is what we call reduced row echelon form. This is kind of our ideal form. You'll notice that on our coefficient side, we have 1, 0, 0, 1 on those, and the other side, x, y, it's going to equal a number for those. And so you'll see when I get it in this form, what it tells us in our examples. Okay. All right, the rest of those are examples. So let's just get right into those. So let me stop sharing and go to the board. All right, let me get my page here. So examples. First, determine the order. Okay, so we want to know what is the order of the matrix. So 1, -3, 0, 6, 2, 5. All right, so hopefully we see here, we do our rows first. So 1, 2, 3. That means this is a 3 by, and then our columns 1, 2, 2. So this is a 3 by 2 matrix. Okay, so let's see another one here. Right. So for this one, our rows, there's only one row, and there is 1, 2, 3, 4 columns. So this is a 1 by 4 for those pieces. Now you don't need to draw all those little lines in here. You can be able to look at it and tell me the answer on that one. That would be the case, but I doubt we have any question like that on your exam. Okay? But you do need to know that because it's going to be important later on. Writes the augmented matrix. Okay. So we have 2x minus y equals 7. X plus 4y equals 5. So this will give us the matrix here. So we have here 2, -1, the equals, and then 7 for our first row. And our second one, we have +1, 4, and then equals 5. And there's our augmented matrix. That's all we do. Okay, so when it asks for that, we're just plugging those pieces in. Again, we have to be able to do that because it's going to be important in just a moment. X minus 2y plus 3z equals 12. 2x minus 4z equals 8. And then 3y plus z equals 7. So we can still even do bigger matrices here. Let me move my chair out of the way. So to get our augmented matrix there, it's going to be just a little bit bigger. But we still do the same things. 1, -2, 3. So 1, -2, 3, and then 12. 2. But notice there's not a y there, so that's a 0. We still have to have something in its place. And then -4 and 8. And then here there's no x, so 0, 3, 1, and 7. And that's the augmented matrix. Those brackets around the edges there are important. They open and close the matrices. A line at the equals is important because it separates out the variables from just the number. So we've got to be able to look at those pieces and work with them. Okay. All right. So that gets us through kind of the real simple pieces. So now we want to start solving. Let me erase this here. I need a little bit of space. right, solve using, I'm going to use Gauss-Jordan elimination. I will accept Gaussian elimination. I know the difference between the two. Your other instructor may show just Gaussian elimination. That's fine, but you will have to do one or the other for these. All right. All right. So x minus 4y equals 9. 2x plus 5y equals 5. Now we are going to need a little bit of space here, so we do want to be careful on these things. Okay. All right. The first thing that we need to do when we're going to do Gauss-Jordan elimination is to set up our augmented matrix. Okay. So let's do that. This needs to be rewritten. 1, -4, 9, and then 2, 5, and 5. Okay. Now you got to be patient. It's a little bit of a tedious process, and you got to just do things over and over again, and that's fine. Okay, but we have to make sure that we're doing those pieces. All right. Now our goal here is going to be to create that row echelon form. So our goal, I'm going to put it over here, is for it to look like 1, 0, 0, 1, and then some numbers, an x and a y value. Okay, they're going to be numbers, not variables for those. Okay, but we're looking to make this side look like so, and we can do certain things to make that happen. Okay, so let's try to walk through that process and do those things. All right. All right. So the first thing here is we need a 1. We're going to start. We're going to do a U shape. We're going to start here at this. I want to make this a 1, then a 0, then a 1, then a 0. I want to make that direction when I'm working through these pieces. Okay. So first one, that's a 1. So we're good. We don't need to do anything there. You don't need to draw that line and the check mark. I'm just trying to show you we're good. So that means I can move on to my next one here, and I need to make this a 0. Now to make things 0, the only way to get to 0 is through adding or subtracting. You can't divide or multiply to make a 0 without making everything 0. Okay, but we got to do things by using the other row. Okay, so what we're going to do here is we take whatever this number is and we're going to do the opposite. So that's a positive 2. Right over here, I'm going to write -2, and we're going to multiply it by row 1. And then add that back to row 2. So every time we're going to have this pattern, we're going to do the opposite of this times the other row added back to this row. Essentially what we're doing is elimination method all in one big swoop. Okay, that's what we're doing here. We're just doing a lot of steps at once, and we're showing that right here. Okay, for those. And you do need to write this in order to move on through this. I want to see, I don't want to see a matrix, and no reason of what you're doing. You should be writing what you're doing to the side. Okay. All right, so let's do this. We're going to do -2 times row 1 plus row 2. And so we just do one thing at a time. So let me erase these pieces so they're not in the way. And we're going to create the new matrix. Let me get my blue marker out here. Okay, so this is going to equal. We're going to have another matrix. So row 1 is not changing. 1, -4, and 9. Because we want that to stay a 1, right? So we're not changing that one. We're changing row 2. So -2 times 1, that's -2, plus 2 is 0. -2 times -4, well, that's going to give me 8. 8 plus 5 is 13. negative 2 times 9 is negative 18, plus 5 is negative 13. And now we've created that 0. We finished off our line from that. So again, I did negative 2 times the top row plus the bottom row to get rid of those things. Okay. All right, so now we need, so we've got our 1, check. We've got our 0, check. So now we need to move over here and we need to get 13 to a 1. Now, the way we get to 1 is to either multiply or divide. There's a couple of different ways you can write this for these. So you can write it either as 1 over 13 times row 2, so that you're always multiplying, or you can write that as row 2 divided by 13. Those are the same thing mathematically. I'll allow for either one on that, okay? Piece, you can write it either way based on how you like it for those, okay? But they are the same thing. All right, so let me move up here. Okay. All right, again, I'm only doing stuff for row 2 here. So row 1 is going to stay the same. So 1, negative 4, and 9. And then row 2, we're just going to say divide by 13 to make it easier. 0 divided by 13 is 0. 13 divided by 13 is 1. Negative 13 divided by 13 is negative 1. Okay. All right, so now we've gotten our 1, our 0, our 1, and we need to get to 0 here. So this is what we're at finally for that one. All right, so we're going to use that trick that we did a while ago. All right, so get this to a 0. We're going to do the opposite. So 4 times the other row. Well, the other row is row 2. So row 2 plus the row we're wanting to change, which is row 1. Okay, so always remember that. This top one is row 1. This is row 2 for those pieces. Okay, so let's do that. All right, I need my other marker to stay consistent. All right, so row 2 is actually not changing. So 0, 1, negative 1. Now 4 times 0 is 0, plus 1 is 1. 4 times 1 is 4, plus negative 4 is 0. 4 times negative 1 is negative 4, plus 9 is 5. Okay? All right, now, a couple things before we finish up on this, because we're pretty well done for this. When I am doing my row pieces, notice when I was changing row 2 here, I put this even with row 2. I changed row 2, I put it on row 2. I changed row 1, I put it with row 1. That's going to help you keep up with what you're changing. Okay, so you do want to do that to help with those pieces. Is it 100% necessary? No, but is it going to help you? Yes. All right, well, finally here, what does this tell me? Well, this column we said earlier represents the X values. This column represents the Y value. So this means this is telling me X equals 5, Y equals negative 1. Okay, because this is a 1X, no Y equals 5, so X equals 5. No X plus Y equals negative 1, so Y equals negative 1 for that. Okay, and then you'll need to see how they put it in. This can be written as an ordered pair, 5, negative 1. Since we're doing a system, we can write it that way, or they just may say X equals or Y equals. So pay attention to your instructions on how they want that written. Okay. All right, let's do one more. Now, we'll go ahead and erase this. Remember, that's our goal, to get to this form for that row echelon form. All right, and I can leave that instruction up there so that we know what we're doing. Number 2, 2x plus y equals 1. 3x plus 2y equals -2. Okay. Get a sip of coffee here. All right, so the first thing we want to do there is write our augmented matrix. So we're going to get 2, 1, and 1, and then 3, 2, and -2. All right, now we've got to go through that process. The first thing that we want right here is that to be a 1. Since it's not a 1, we need to divide that off. Okay, so I'm going to divide, or I'm going to multiply by 1/2. I'm going to say 1/2 times row 1, or row 1 divided by 2, the same thing. Okay. All right, so that brings us to our next matrix. So let's divide all those by 2. We're going to get 1. 1 times 1/2 is 1/2. 1 times 1/2 is 1/2. And we didn't change row 2 yet. So 3, 2, -2. Okay. All right, so we got our 1. So now we need to change this 3 to a 0. So to do that, we do the opposite. So -3 times row 1 plus row 2. Okay. So let's bring that up so we have room. Okay. So the first row is not changing. It's 1, 1/2, 1/2. And then the bottom, so -3 times 1 is -3, plus 3 is 0, which is what we wanted. -3 times 1/2. Now that's -3/2 plus 2. Right? So we're going to get 1/2. Just so happens. Right? Now, you can do all that math in your calculator. You can do it to the side there. But again, that's going to give me -3/2. 2 is 4/2. So -3 plus 4 is the 1/2. Okay. All right, -3 times 1/2 is -3/2 plus a -2. Well, that's still 4/2, but it's negative this time. So -3 and -4 give me -7/2. Right? Again, those are just basic fraction skills. You should know that by now. So if you need help with that, make sure you get with me or an SI. Use your calculator, those types of things to be able to get those. All right, we have our 1, we have our 0. So now we need to change the 1/2. Well, to get that off, make that a 1, instead of multiplying or dividing, we want, instead of dividing, really, we want to multiply by 2. So we want to say 2 times row 2. Okay, so if we do that, that's going to negate that fraction. And so we get our top still is not changed. 2 times 0 is 0. 2 times 1/2 is 1. 2 times -7/2 is -7. So we're getting closer. All right, so now we need to make that 1/2 a 0. Okay, so here we do the opposite. So -1/2 times row 2 plus row 1. We're always going to multiply by the opposite row, the other row, and add back to what we want to change. That's going to keep a consistent pattern for those. All right, so let's do that. Now, row 2 is not changing, so I'm going to go ahead and write it down. And it's in the row for row 1. So (1/2 times 0 is 0, plus 1 is 1. (1/2 times 1 is (1/2), plus 1/2 is 0. (1/2 times -7 is a positive 7/2, plus 1/2 is 8/2, which is 4. Okay? So again, it's all just fraction work there. But we have 1, 0, 1, 0, so that means x equals 4, y equals -7, or 4, -7 for our ordered pair. Okay? And so that's how you work through these matrices. All right. Now, if you want to look at the other method, if you can, those that are in my class can contact me directly for just Gaussian elimination, or speak to your other instructor. He as well knows how to do that for the co-rec class. But I like this one. It just goes one more smooth step there because Gaussian stops here and you got to do other things with the numbers. So just by doing that one more step on those, then you have your answer. So that's why I like to do it that way. Okay, but we'll have to show this on an exam. So make sure that you know how to do at least Gaussian, showing your steps on those pieces for them. Okay, and that's what we have here for solving with matrices.